We're looking at completing the square. I have another example here. I showed the solutions in the original video, in the full video. So I'm going to show how to do this problem, or another example of doing this problem of completing the square and using this method to solve a quadratic. As you saw in the other video, there's more than one way to do these problems to solve a quadratic. The first, and the one that I would recommend trying right away, is can you factor it? Factoring is definitely going to be the fastest way if it's possible. So if the coefficient is 1, the leading coefficient is 1, we want to try and find two numbers that multiply to -4, that also add to 6. I can't think of any, and so we're not going to be able to do that. So factoring is out. This is where completing the square can come in. Completing the square works really, really well if the middle coefficient here is a whole number, and it works even better if it's an even number. However, odd is fine. It's just if it's a fraction, it's just a little bit more complicated, but it's still doable. There's nothing to stop you. To complete the square, and I'm not going to spend much time at all on these geometric pieces again, but to complete the square, what we want to do is just concentrate on the ones that have the x. So those rectangles and squares that have an x with them. So we're going to try and move that 4 to the other side of the equal sign. So x squared plus 6x equals a positive 4. We're going to add 4 to both sides of that equal sign. And again, we do that because x squared plus 6x minus 4 is not a perfect square quadratic. We want to make it 1. And so when we rearranged this, what we had to do to get the almost square was, x, is we had to take that middle coefficient, that's 6, that rectangle here, and cut it in half. So we could put half on the bottom and half on the top. And we're just left with this piece that we're missing down here. So half of 6, we take 6 divided by 2. We're going to get 3 and 3. And then to get this piece that we're missing down here, which is where this hole comes in, is that missing piece, we do 3 times 3. So we square it. So if you don't draw the pictures, you're going to take the middle coefficient, the coefficient b, and you're going to half it and square it. 6 divided by 2 is 3. 3 squared is 9. If I do that, x squared plus 6x plus 9 is the same as x plus 3 squared. And that's the purpose. If you FOIL that out, you're going to get the same thing here. That's the purpose, is to get it to be a square quadratic like that. However, if you add 9 to the left side of the equal sign, you got to add 9 to the right side of the equal sign. 4 plus 9 is going to give me 13. All right. To get rid of that square, I can either ask something squared equals 13. I don't know off the top of my head. It's some decimal that never repeats and never ends. It's an irrational number. I'm going to take the square root of both sides of that equal sign. The square and the square root cancel because they're inverse operations. X plus 3 then equals plus or minus the square root of 13. I can finish that. I'm almost done. I'm going to subtract 3 from both sides. X equals, I'm going to write it this way. -3 plus or minus the square root of 13, simply because that's the way the quadratic formula ends up looking. If you subtract 3 from both sides and you write it as plus or minus the square root of 13 minus 3, because you subtracted 3 from both sides of that equal sign, that's okay too. There's nothing wrong with that. It's just not kind of the standard way to write it. And so I'm going to write it this way simply because that's just because. But if you write it this way, there's no points lost. You're fine. That's perfectly correct. But that's using the completing the square method to solve that quadratic.